So we've looked at hypothesis testing or significance testing for continuous variables already. We have a way of doing that. It was finding a critical value and seeing whether the sample mean was in the tail or in the bulk of it. And if it was in the tail, either side, we rejected H0 and accepted H1. This is an alternative approach, and we're going to have a couple of examples here. They're not going to be wordy examples. We're going to sort of summarise the key bits as we go. So, first off, we have a population of things which we are going to call W. I'll sort the focus out. And W is normally distributed with a mean of 70, a standard deviation of 7.5. So I've put 7.5 squared in there for the variance. A sample has been taken of size 90, and the sample mean, W bar, is 71.6. We have been asked to test two hypotheses. H0, the null hypothesis, is mu equals 70. In other words, nothing has changed from what we have known about the population. H1, the alternative hypothesis, is mu is greater than 70. What sort of test are we going to do? Yeah, so it'll be a one-tail test. And we are told the significance level we are using is going to be 5%. Okay? So that is the information that we are given in the question in sort of summary form. Now, we're going to do this now without working out a critical value. We are going to do everything in terms of the numbers that are in the normal distribution table. So you need to get your tables out, have those in front of you. And that normal distribution in the tables we denote as Z, which is normally distributed with a mean of 0 and a standard deviation and variance of 1. So we're going to look at now things in terms of Z. Now Z is always equal to your value, take away your mean, divided by your standard deviation. Yeah. Okay. So for x bar, what we are going to do, Z will be equal to the x bar value we have observed, take away the mean, divided by, and what's the standard deviation of x bar? Yeah, you're giving it to me in numbers, so can you give me that in symbols?
Sigma over root n.
Yeah, sigma squared over n, all square rooted, or as you said, sigma over root n. It's the same thing. So we are going to do everything in terms of this statistic Z. Okay, where Z is normal, 0, 1. Now, if we just draw a sketch, now this is in terms of Z, where it has got a mean of 0. Are we interested in this question in the upper tail or the lower tail? How do we work that out? Yeah, we're interested in the upper tail because of that inequality sign there. And we are interested where there is 5% probability from that significance level in that upper tail. So can anybody tell me, what is this value of Z here? From, thank you, 1.645. Okay, and you can get that from the bottom of the tables if you look up 0.05. Sorry, 0.95. And that is one of these numbers that you will memorise. So all we actually need to do now is what? Check what the Z is equal to from here and just compare it with that value there. So for the information we had, if I go down so we can see it all, our x bar, our sample mean here, was 71.6. The population mean is 70. Sigma squared is 7.5 squared. N, our sample size, was 90. Square root that, work out Z, plug it in a calculator, tap away. Hopefully you'll get the same answer that I've got written down in front of me. 2.02. 2.02 is somewhere in that tail. So, what?
the most acceptable alternative.
Exactly right, yeah. We will reject H0 and we will accept H1 because we are over in the tail. So therefore we are assuming that mu is indeed greater than 70 because our Z value was in the critical region. So this is an alternative way of doing it which can save time sometimes. Are we all happy with the logic of that process in that example? Okay, right. We'll do another one. Okay, can I vanish this one from the board? Okay. Right, so next one. We have got a distribution for D. D is normal 0.58 and standard deviation is 0.015. We have a sample size of 50. A test statistic, our sample mean is 0.577. Focusing really much. Right, and we are going to test at the 1% significance level. The hypothesis H0 is that mu equals 0.58, i.e. nothing at all has changed. And H1 is that mu has changed from 0.58. So immediately you are thinking two-tailed test because it's a not equal to, yeah. And I would, in every question you do like this, just sketch a little diagram. So if we're doing it this method, it'll be Z, the mean will be 0. How much area do I want in each tail? Yeah, 0.5%, because I'm splitting that between two. So each side, that is 0.5%, which is 0.005. So, if you use the very bottom of the tables where you can do this backwards thing for sort of popular values, what are these two Z values here? Okay. Yes, I think I heard the same thing twice. 2.576 and minus 2.576 by the symmetry of it all. Okay? Our Z value is going to be, well, we said it's x bar minus mu over sigma over root n, if I write it differently. Ooh. Well, I'll put my sigma squared in there. Sigma squared over root n. Bung your numbers in. What value are you getting for your Z? Lots of tapping going on. Anybody got an answer?
Minus 1.414.
Yep, that's what I think it should be. Okay, and that is going to be here somewhere. It's not in a critical region, so what do? We accept H0, yeah. Not in a critical region, we accept H0, so we state that mu, as far as we're concerned, is still 0.58. Are you okay with the two-tail one? Okay, so I'm going to give you just some information, see if you can just finish the next one off on your own. So the third one we're going to look at, we are starting X, normally distributed 185, 15 squared, sample size 25, sample mean 179, 5% significance level, H0. What will H0 be? You can tell already. Yeah, mu equals 185. Against H1, mu is less than 185. So you are thinking one tail. Okay. So if you can do your drawing, do your calculation. I'm going to freeze it in the class, but I'm going to keep on writing on the video. And the final one, the fourth one, we've got T normally distributed. We don't know what sigma squared is, haven't been told, but we do have an unbiased estimator for it. We do have down here sigma squared hat. We have our hypotheses. It's a not equal to, two-tailed test. 5%, n is 50. See what conclusion you come up to.